Well, it's time to discover the slope formula. We've been talking about it, I've been prefacing it, kind of got a feel about what slope means over the last several videos. Last video we really delved in and figured out the first little formula for slope, this rise over run thing. Now it's time to find the formula. I am not the type of teacher to just give you a formula without showing you exactly where it comes from. I don't think that's worth anything. So we're going to discover where the slope formula comes from. Why does it look the way it does? What's it do for us? And by really understanding where the slope formula comes from and what it's really doing, we'll make less mistakes when we're plugging in numbers. Frankly, that's what it is. So let's talk about discovering what the slope formula is. So what you've noticed on the board right now, I've got a random line. Yeah, we can say the slope is positive as we move from left to right. We're climbing. We'd have a positive rise and a positive run, of course, we're moving to the right. But I'm not concerned about that. What I'm concerned about is a way that's going to allow me to find the slope between any 2 points on a line without having to draw it, without having to look at it, without having to count up and over. And I'll show you that in a little while, next video. But that's what we're getting to. So let's start with random line. Now, let's put 2 points on this line. We know that we've got to have at least 2 points to even make a line, so we're going to have 2 points to also find the slope of that line. So this whole slope formula is predicated on the fact that you got to be able to find 2 points to find the slope. Let's create some points. Now as we move forward, please don't miss this. I'm not picking specific points here, because if I pick specific points and try to find a formula for that, what's going to happen is that formula is only going to work with those specific points. So I'm going to pick 2 random points, let's call them A and B. And we're going to be finding the slope between A and B. The slope between A and B is going to be a slope between any 2 points. The slope never changes. It's a constant rate of change that our line is increasing forever or decreasing forever. That's why we get a line. If we alter the rate of change from point to point, we no longer get a line, we start getting curves. The study of the slope of curves, what? It exists. It's called calculus. When we get to calculus, we study what the slope of a curve at a point is. Very interesting stuff. It's kind of magic. It's really cool. I hope you get there. I really do. I'd love it for you guys to make it past this and get to the stuff where you get to do cool math. Not that this isn't cool, but it's more cooler later. Anyhow, the slope of a line doesn't change. So if we find the slope between A and B, we'll find the slope of the line between any 2 points. So we're leaving A and B as I don't know what those points are. Frankly, I don't even care. We're going to find the slope. Now, think back for a second. If you plotted a point, if I said, hey, plot point A or plot point X, whatever, what would you need to know in order to plot that point? Well, you need to know coordinates. How many coordinates does every point have? If we're talking about a flat surface, a rectangular coordinate system, how many coordinates does every point have? Yeah, they got 2, and X comes first, and Y comes second. So every point ever has an X coordinate and a Y coordinate. Let's put those up there. So if every point ever has an X coordinate and a Y coordinate, that means A has an X coordinate and a Y coordinate. And that means B has an X coordinate and a Y coordinate. And right off the bat, you might notice a problem. Because if I say, hey, that's the point XY, and that's the point XY, and I'm talking about 2 different points, that's a problem. Because there's no way to distinguish between the 2 points. Do you see that? Do you see what I'm talking about? Do you see that if I say, hey, go to the coordinate X, you go, well, that's a problem. So what we're going to do is we're going to give this thing a subscript. Superscripts that are written above and to the right of the variable are reserved for exponents. Subscripts tell you what exponent or what variable you're talking about. It's a way to number our variables. It doesn't really do anything besides say, hey, this is the first one, this is the second one. So we're going to do that. So instead of just X and Y, let's call this X1 and Y1 because, well, it was our first point. Now, before you ask a question, I always get asked this question. Does it matter which one is your first point and which one is your second point? Which one you call X1, Y1, and which one you're going to call X2, Y2? Does it matter? No. The slope formula does not care what order you have your points. It's going to work out either way that we get the correct slope. That's kind of nice. So no matter what order your points are given in, It doesn't matter. It really doesn't matter. One of them's called the first one of them's called the second one. That's kind of nice. Oops, I made a big mistake. Don't do this. Please don't do this. If you're going to have a point, it needs to have an x coordinate and a y coordinate that have the same subscript. So we'd have x1, y1, not x1, y2 like I wrote. So this is our first point. x1, y1 says, hey, let's consider that to be point A. And then x2, y2, let's consider that to be point 2. Now, why don't I have specific points again? Why don't I want to put up there, that looks like 1, 2, maybe, I don't know. That looks like 5, 6, whatever. I don't want that because then the formula that we're about to create would only work with those points. That's silly. I want a formula that has x's and y's in it. x1, y1, x2, y2. That way I can plug in any 2 points and it will give me, without graphing, what the slope is. That's awesome. That's what we're trying to do. So I call this one x1, y1, this one x2, y2, just to distinguish between the 2 points that we have to have. Now here's the big deal. All we know about slope at this point is that slope is a ratio and then it equals rise over run. Now, if we're somehow able to identify the rise and identify the run with these points, then we can go ahead and translate this. That's a formula. That's the first one. If we know slope is rise over run, and we know what the rise is, considering our variables, and we know what the run is, considering our variables, then we can translate this to a formula. Now, I want you to think back. What is the rise? Is the rise the vertical component or the horizontal component? Kind of makes sense that if we're rising, we're talking about going up or down. Negative rise would be falling. That's how to interpret this whole slope idea, with rise being positive means up, negative means down. Now, what variables do you think would have to do with rise? I mean, if rise is talking about this way, what variables talk about this way? Why? Yeah, for sure, why? So all we've got to do is figure out the y components for this point and the y component for this point and find the difference between them. So let's go ahead and let's try that. This is weird, but how high is that point? In other words, what I'm asking you is how far up on the y-axis would you have to go to reach the level of this point? So it's not at 0. It's not at this level. It's a little bit higher. You could probably stop or put your pencil where the level is. If you hold it this way, right there, I would stop at the level. This would be the level or the height of that point, considering just the vertical movement, considering just along the y-axis, and that is precisely what rise does. Rise only cares about this way. That's all it does. So I need to know how far up this point is. So how far up this point is right there. How far up this point is? Well, let's do it. This rise was right about there, or this y component, the coordinate, was right about there. And the component of point B is probably right about, looks right about there. Does that make sense to you? Does that make sense that that's the height of those 2 points? You go, well, yeah, it's points here, it's about that high. Points there, it's that high. Now, here's the big part. What's the component of that? I mean, like, how high is that really? I don't want you telling me 3. I don't want that. It looks about 3. Because then you could only use 3. I don't want that. I want to know for any point what the height is given by. Think about that as we go ahead and we do our x's real quick. I want your brains kind of thinking about that right now, though. So now we need to know the run component. Oh, the part on the x-axis. So how far over our point A is. Seems to me that this is about, okay, well, it's not here. Looks about, almost gave it away. There and there. That, as far as the x-axis, would give you where we are for this point and this point. Remember that we're on a rectangular coordinate system. We have 2 numbers for every point. An x number, how far over we are on the x-axis, and a y number, how far up we are on the y-axis. So x and then y. let me make it kind of easy because I always I lose students right here when I just give this away. So I want you to pretend it's not the point, but just pretend that this is the point 3 comma 4. Just pretend. I'm going to erase that in just a minute, okay? Let's pretend that's 3 comma 4. What would this number be? Right there. We've gone backwards and forwards some points. Do you remember that? We went and we plotted points from their coordinates and we got coordinates from their points. Basically, we're doing the latter of those two. So if I tell you, hey, that point's right there. That's right there. 3, 4. That's 3, 4. What's this part? How far would you have to go over to get to the point 3, 4? X, oh, whoa, that's kind of cool. The x coordinate is 3. I'm talking about how far over we are on the x-axis. This is not unimportant. This is really key that you get this. That number, that 3, tells you this number. Do you get that? The x coordinate literally does mean how far you are over on the x-axis. I know we've talked about that, but sometimes it never sinks into like right now. So that number gives you this number. So that's 3. If this point is 3, 4, that number is 3. How far are you over on the x? How far up are we then? Seems to me to be the y coordinate. We'd be up 4. And that's exactly how we get to that point. If you start at the origin, say plot 3, 4, you'd go over 3, you'd go up 4. That's exactly what we're doing in reverse. Now, we don't have 3, 4. But what was important is this. The x coordinate literally tells you how far over you are on the x-axis. The y-coordinate literally tells you how far up we are on the y-axis. So now put your brains in variable mode, okay? I don't have 3, 4. I don't have this as an actual point, so I'm not going to put 3, 4 down. I don't want to ruin that for us. I want to give you, it's not 3, 4 anymore, but it is specific. It's x1, y1. And when we put those subscripts down, we are talking about a specific point. So it's going to have actual numbers. And I'm not talking about x and y as variables right now. I'm talking about this is an actual point. x1, y1 gives you real numbers. You're going to put those in there. So we're not talking like something that can change when I have a situation of 2 points. Those 2 points are 2 freaking points. So let's pretend it's like 3, 4. I knew that if this was 3, I had 3. If this was 4, I had 4. Now I don't have that, but I still have numbers. What's this number? So it's no longer 3. What is it? It's got to be the x-coordinate. It's got to be. So what the x-coordinate tells you is how far over you are on the x. So if you have a point with an x-coordinate of x sub 1, 3, 5, -2, who cares? It's telling you how far over it is. So if I give you a point of x1, y1, your x-coordinate is how far over you are on the x. That's got to be x1. X sub 1, which means that our height is given by the y-coordinate, y sub 1. Why don't you right now try to fill out the other ones? How far over is this? Well, if x-coordinates always give us our distance along the x-axis, how far we are from the origin, then this must be given by the other x-coordinate. And it should be not common sense, but I mean, it should be kind of intuitive here, that the x-coordinates have to do with the x-axis. It tells you where you are. And the y-coordinates have to do with the y-axis, tells you where you are. We're actually really close. So here's a little recap. We know that slope is rise over run. The comparison of vertical motion along the y-axis compared to horizontal motion to the right along the x-axis. Slope always reads from left to right, which is why the run is always to the right. That's what we're talking about here. I'm starting with 2 points. I don't know what they are, but I do want specific points. I do want to be able to plug in specific points. That's the x1, y1 for the first point. And x2, y2 from the second point. Does not matter which one you call x1, y1 or x2, y2. Doesn't matter. What does matter is that we understand your x-coordinate gives you your distance on the x-axis for both points. Your y-coordinates tell you the distance on your y-axis. If you get that, if you're with me still so far, that is awesome because we are almost done. Let's talk about the rise first. You see, if the rise is just the change in height, vertical motion, from one point to another, then really our height is just the distance from, well, A's got a height right here. That's cool. That's the y-coordinate. B's got a height right here. It's just that distance. You can make a little dotted line if you want. Kind of missed, but forgive me. The vertical change, the rise, is just the distance from those two y's, those two coordinates, the y coordinates. Does that make sense to you? That if we're talking about y motion, vertical motion between 2 points, vertical movement really, how much we've changed from one point to another, we're literally just comparing y coordinates. We have to be, because that's the only things that talk about vertical stuff, is stuff along the y. So if we find the distance between the y coordinates, we will find vertical change. Does it make sense? It should make sense right now that y coordinates have to do with vertical change. Now, bigger question, how do you do it? How do you find the distance between any two numbers? How do you do that? If this was 10 and this was 3, it's not, but if that was 10 and 3, what would the change be? Well, it wouldn't be 10 because you're not changing from here. You're not changing from the origin. You're changing from where y started to where b ends. That's the change. So what's the distance between here and here? 3 and 10. Yeah, it's 7. Now, how do you find it? Because that's the key. How do you find the distance? Well, you just thought about it. Really, you're subtracting. You're taking the 10 and subtracting off the 3, the part that you didn't need. The total height from here to here is 10. From here to here is 3. The part you didn't need is the 3. We subtract it away. So 10 minus 3 would give you the 7 that we're looking at. That, in general, is how you find the rise. We look at the y coordinates, and you just subtract them. That, by the way, ladies and gentlemen, is how you find the distance between any two numbers. Just subtract them. So we're going to take our, now which one would you do? Would you do 3 minus 10? Would that seem right to you? Or would you do 10 minus 3? Probably the 10 minus 3. Probably the second one minus the first one. That is exactly what the rise does. So the rise says the distance between any two values is given to you by subtracting one from the other. That right there is the rise. If you want to, why don't you try to figure out the run right now? Now, run always has to go to the right. So to find the distance between these two numbers, if this was, again, 10 and 3, if that's 10, that's 3, the distance is 7. You're still subtracting. That's how you find the distance between any two numbers. So our horizontal movement, does it make sense that horizontal movement has to be along the x? It's the only thing that talks about horizontal stuff. So that means if I'm talking about horizontal movement along the x, I'm talking about x coordinates. I'm talking about the distance between these two values, x2 minus x1. That's it. You've got to be able to find the distance horizontally between 2 points. So this is why we have to have 2 actual points, so that we can plug in these numbers. We've got to have 2 y coordinates to figure out the distance between those points. We have to have 2 x coordinates to figure out the distance horizontally between those 2 points. When we do that, when we subtract this coordinate minus this coordinate, the coordinate of one point minus the other point, we get what's called the run, the horizontal movement from left to right. I'm really hoping that makes sense to you right now, that we're comparing y coordinates for rise. Should make sense. It's the only thing that talks about vertical. X coordinates for run. That's the only thing that talks about horizontal. Since rise and run deal with those 2 components, and slope is the relationship between them, that ratio, we're done. So look back at the board. What expression do we have for rise? Rise has got to be vertical. That means y stuff. That means the comparison or the difference between y coordinates. So our slope, yeah, I know it's rise or run, but we have something for rise now. Something that allows us to plug in points and not just have to draw a picture and count. We have now that the rise is always the difference between the y coordinates. That's what that said. The run is always the difference between the x coordinates. There's a couple things I want to point out. I hate it when students know how to use a formula but have no idea what it means. Drives me nuts. Probably drives you nuts. You're like, why are you using it? I don't know. Teacher told me to. Yeah, that sucks. Okay, that's not the way to learn math. That's not the way to be successful at it, at least. What this is doing, I need you to see it. I need you to see how this actually works. That's a lot of variables and numbers and crap flying up there. What the heck is that? All it's doing is giving you the change this way between your points. That's it. That's all the y2 minus y1 does. It says take your y coordinates, subtract them. That's how much you change this way. That is what rise is. Compared to your change this way, horizontal. And that's exactly what slope does. It takes your vertical change, it compares it to your horizontal change. This is just vertical change. In calculus, we deal with this stuff too. It looks almost identical. We use a delta y and a delta x to represent change, but it is this. Just subtract your y coordinates, that's your vertical stuff. Subtract your x coordinates, that's your horizontal stuff. That is the slope formula. A couple ways to remember it. I told you the order of the points don't matter, but the relationship on how you write them does matter. Here's what I want you to look at. This isn't going to be in a textbook or anything, okay? But I want you to notice something. If you're looking at this, this is 1 point. x2, y2 is your first point. Make sure that when you're doing the slope formula, that these two numbers give you a point, that you're trying to find the slope between these 2 points, okay? That these two give you 1 point, and these two give you the other point. I don't care what order you have them. It could be first. It doesn't matter. What does matter is that if you start with 1 point for your numerator, you have to start with the same point for your denominator. That's got to be there. If you end with 1 point, you're ending with the numbers, the coordinates from that same point. The easy way to look at it is go like this. That should be a point. If you're looking at it this way, x2, y2 is 1 point. That should be another point, x1, y1 is another point. That's the way to check your work pretty quickly to make sure you're not accidentally kind of mucking up some orders here. You change the order, you're going to get the reverse of the slope that you want. You're going to get the opposite side of what you want. Do not do that. The other thing to remember is that the rise is always on the top, so your y's have to be on the numerator. The run is always on the bottom, so your x's have to be on the denominator. So that's the keys here. This gives you 1 point. This is from another point. Y is on top, X is on the bottom. The last thing, we generally don't just call things slope. We usually have variables. And the reason why we have variables to represent ideas like slope is so that our formulas work better later, so that we can use a letter to represent this word slope. So we're going to do that. The letter that always represents slope for us is a lowercase letter m. Why m? I don't know. I really don't. I probably could look that up. Probably Google it. If it's online, it's got to be true, right? So the letter that we're going to use is m. That's universal across all of your algebra, that m is going to mean slope for you. So m is slope. What that means is slope is y2 minus y1 over x2 minus x1, and that's fantastic. You might have seen this before. You've had some sort of math at this level, but that's where it comes from. That is the slope formula at work and the discovering of it. Now, stop. Before you go any further, we have about maybe 2 minutes of stuff to do, but before you go any further, ask yourself, do you understand that? What's m stand for? M stands for the slope. It's talking about the slope. It's talking about how a line is climbing or falling or not climbing or falling or climbing infinitely and not even moving to the right. It's talking about that relationship. So how we find it is we compare the rise to the run. The rise is y's, the run is x's. That's it. That's where this stuff comes from. Walk through that again. Make sure you understand what that means. Now, on the next little part, we're going to talk about, well, how lines look. Well, we're going to look at how lines behave in order to find the slope. Let's check this out. Remember that we always read slopes and lines from left to right. Is this line climbing or falling as we move from left to right? We don't go this way. We don't say, oh, that's falling from right to left. It's backwards. We're reading from left to right. Is that climbing or falling? Yeah, it's clearly climbing. Talked about it a little bit in the last video. This is going to have a positive slope. The way we say that, our slope, our m, would be positive. All positive numbers are numbers that are more than 0. So our slope would be more than 0. 1, 2, 3, whatever it is, fractions, who cares? But it's going to be positive. Slopes that decrease as we move from left to right, those slopes are negative slopes. That means that m would be less than 0. Can you think about that? If you went from this point to this point, do you see how we'd be climbing along the rise? Our values would subtract and give us a positive number. The run would always be positive, because if you always subtract large numbers minus smaller numbers, you get a positive, no matter what. Here, the reverse is happening. We're going from point to point. We're subtracting small numbers minus larger numbers. That's a negative. The run's still positive, but you're dividing a negative by a positive. Lines that climb, positive slope. Lines that fall, negative slope. How about lines that don't? What about lines that don't climb or fall? Go from point to point. How much do you climb from here to here? 0. How much do you run from here to here? How much do you go to the right? Several units, but you are going several units to the right. So basically your slope, if your rise is 0, you're not climbing, you're not falling. Can you, oh, this is beautiful. Can you divide 0 by a number? Yes, and you get 0. So no rise, lots of run, your slope is 0. Every horizontal line has a slope of 0. Think about it for a second. Let it sink in. Okay, let it sink in. If this is positive and this is negative, then right between positives and negatives, what's the oh, beautiful. What's the number between positives and negatives? Positive numbers, negative numbers, 0, right in the middle. Horizontal lines have a slope of 0. I've told you 2 reasons why right now. You can divide no rise by run. 0 divided by a number is 0. This is the last one. It's weird. How much do you go up as you move to the right? Oh, crap. Does the line move to the right? No. Because of that reason, because you go, wait a minute. If slope is rise over run, if slope asks, how much do I go up or down compared to how much I go over? And I don't go over, I can't do the comparison. There's no way for me to do it. So if you have no over, you can't answer the question, how much do you rise? Because the slope is how much do you rise compared to how much you go over. If you don't go over any, you can't answer the question. You can't even define the question. That's why this is called undefined. The slope here would be undefined. Check it out. The mathy way to look at it is, how much do you go up? A whole freaking lot. How much do you move to the right? You don't. So you have some number, it's actually infinity, over 0. Can you ever divide a number by 0? No. You can divide 0 by a number. Yes, that's fine. You cannot divide a number by 0. So you're smoked. You're done. That would be undefined. So I've given you two ways to think about that here as well. Answering the question, how much is rise over run when you don't have a run? How much do you go up or down when you go to the right? I don't go to the right. Yeah, but how much do you go to the right? I don't. Oh no! And you get undefined. You can't even answer the question. That's undefined. The other reason is because we divide by 0. Kind of the same reason, a different way of thinking. In general, every vertical line has a slope which is undefined. You divide it by 0. That's the idea. We've taken our points. Notice we didn't even pick actual points. We picked points that we can plug stuff into. We have some spaces to plug in any 2 points. 1 point here, 1 point here, and it will give you the comparison of rise to run, vertical motion compared to horizontal, and that by definition is our slope. That's your slope formula. Positive slope, negative slope, in between 0 slope, vertical, no slope that we can even talk about, called undefined. Watch the next video. We're going to discuss how to find slope between 2 points graphically. In the video after that, we're going to do it between any 2 points that I give you without even having a graph, and that's very nice. See you next time.